All right. So again, last time what we were working on were some examples from chapter 6. And again, basically here, we're working on those kinds of questions where, you want to withdraw a certain amount, you want to, for retirement, those kinds of things. You could use the TVM solver if you want to. What I'm doing now is I'm going through how to actually solve them using the formulas. I know I did go through the formulas in class, when I was lecturing, that is. But I really wanted to also go through the formula some more and emphasize those, only because most people I found did not like the TVM solver. I mean, that's okay. I mean, I hope I explained it well for everyone to understand. I think I did. But I figured it wouldn't hurt to go through the formulas. I feel like the formulas are conceptually easier, but as you probably saw, the calculations are a little more involved. So, one second. Just had to close the door. Okay, so let's do some more examples now. All right, so in this one, this has to do with retirement, okay? We want to be able to take out $30,000 a year for 25 years once we retire, okay? Once we retire. So, it's a retirement account basically, okay? It is example 12 in the book on page 147. So now the question is, let's say we want to, and also let's assume the account is earning 8% interest, okay? Now, the question is, how much do we have to have in that retirement account to do this? So in other words, we want to know when we retire, what would our starting balance have to be? That's really what the question is asking us. I know I forgot to put in that retirement, that idea, although it is implied from here. But again, it does come from the textbook, and the textbook you have immediate access to, as you should know already. So now the question is, how much do we have to have in our account to pull this off? When we retire, if we want to be able to pull out $30,000 each year for 25 years. And then the question is, okay, assuming we do this for 25 years, how much money are we going to go through? How much total money are we going to use, so to say? If we pull out $30,000 a year for 25 years, well, how much money are we really in total pulling out of the account? And then what we want to know is, how much of the money from the account comes from interest? That's really what part C is asking. How much of that money comes from interest? Now, notice we're making many withdrawals, right? We're not just doing one or two. And that's why we have a payout annuity. We have a payout annuity. So we did see that formula before, so we'll see it again shortly. And remember that formula, we had some variables. So let's get the variables now. So P sub 0 in that formula, that's how much was in the account at the beginning. Again, the formula was in the notes from last time, so I'm not going to state the form. Well, I mean, we'll see the formula again as well. I did also email the notes to you. So the question now is, okay, so P sub 0, that's how much is in the account initially, right? Well, that's what we're trying to figure out, so that's unknown. PMT, in this case, is regular withdrawal, okay? Remember, it could either be regular deposits or regular withdrawals. With a payout annuity, it denotes a regular withdrawal. Okay? It's how much you're taking out every time repeatedly. Notice we're taking out money each year. I mean, usually in the problems, we had taking out money each month. Here, we're taking it out each year. And that's given to us. That's $30,000. The interest rate, we write that as a decimal for the formula. That's 0.08. Okay? How many times is it compounded each year? In a year, excuse me? Well, remember, unless stated otherwise, okay, it's being compounded as often as we're taking out withdrawals or as often as we're making deposits. That's really just a convention the book does. I think they could be different in applications, in real life that is, but then you have to do a lot more work. And we're not doing that we're not doing that here. We're just focusing, we're assuming basically, unless stated otherwise, that it's compounded as often as you make withdrawals or deposits. So since we're making annual withdrawals, it's only going to be compounded once a year. So N is 1. Hope I'm not going too fast for anyone. I don't think I am. Okay. All right. So again, it's only being compounded once a year. And again, the number of years, okay? How long do we plan to do this for? It's going to take about 25 years, okay? It's going to take 25 years. That's what our little t is. So with all this for our variables, okay, we can now use the formula. The formula, this we also saw last time, as you can see, okay? Right? So now we plug in what we had, right? We had PMT was 30,000, right? R was 0.08. N is 1, right? T is 25. And now that we have all these variables in, we have to do some calculations. And that's what I'm doing here. I mean, from here to here, what I'm basically doing is I'm just noting that, well, if you divide by 1, you're not really changing anything. So 0.08 over 1 is just 0.08. Okay, good. Right? Now, remember, when you calculate these, you always want to work from the innermost parentheses outward in the numerator and also in the denominator separately. So essentially, you're going to evaluate the numerator and then you evaluate the denominator separately. I mean, the denominator we already have is 0.08. So for the numerator, I thought I was missing something. We have this now. Again, all I'm doing here is I'm just repeating this. And 1 plus 0.08, we combine that to get 1.08. That's what we have there. Okay, now, right, if we were to raise this to the negative 25, again, this is where a calculator would come into play. Usually with these problems, you want to round to 2 decimal places, only in the very end. So in our intermediate calculations, before the end, I would just use as many as you're able to. I'm using here 7. I just thought 7 would be a good number, that is. Anyway, when we calculate this, we're going to get this number, as you can see. Now we do 1 minus that, and that gives us this number over here. And we're multiplying that by 30,000, and we're dividing by 0.08. Again, it's all in the formula, and we end up with this. And again, I'm rounding to 2 decimal places, okay? I'm rounding to 2 decimal places. Okay? I mean, I will tell you on the final how many decimal places to round to, okay? Good. All right. Okay, so we have that. Now, again, we want to know how much are we pulling out in total from the account? Well, if we're pulling out $30,000 a year, and this is going on for 25 years, we just multiply. We just multiply. We do 30,000 times 25, and that gives us this. Now, we also want to know how much of the money is interest. Well, remember, okay, any amount that's in the account that doesn't come from us, that is, it doesn't come from any of our deposits or withdrawals, is interest. So any extra money that we're not pulling out is going to be the interest in the account. Okay? I mean, the wording I know could have been a little bit better, but I hope everyone understands what I'm trying to say. We're basically determining how much money in the account is from interest. Okay? Well, if we're taking out $750,000, right? And we have this amount in the account, well, anything left over is what is interest. Anything left over comes from interest, and that's why we're subtracting. We're subtracting because, again, we want to know what came from, how much interest is in the account. How much money came from interest? Well, it's anything left over. It's kind of like with the idea with deposits, right? We're putting money in, but if we subtract off how much we deposited in total, well, anything left over was interest. I hope that makes sense. Let me just